Would everybody agree we technically have a sphere and a hemisphere? How do I know I have a sphere? Once we join two hemispheres together, would you be happy that that's a sphere and a cylinder? Are we cool with that? Sphere and a cylinder. Okay, happy days. Next step. It wants the volume. So would everybody be in agreement that we're going to use the volume of a sphere and a volume of a sphere and a volume of a cylinder? That be right? You go to page 9 of your tables and you look for the volume of a sphere. Volume of a sphere is 4 over 3 pi r cubed. Go with that? You look for the volume of a cylinder, and what formula does it tell you? Anybody? Pi r squared h. That's the volume of a cylinder. Just the volume of the sphere is blue. The volume of the cylinder is red. We on board so far? Okay. Nextly, we need measurements. Can anybody tell me what the radius is? 3. Okay. Now here's the tricky parts. Can anybody tell me the length of the green line I'm about to draw? Aliens, where'd you get 14 from? Yeah, it's the radius in every direction. Do you get what I'm saying? 3 up and 3 across. Yes. So its radius is 3, and it's a radius of 3 in any direction. It's half of 6. 6 is the diameter, so 3 is the radius. And it's 3 in every direction. Do you get what I'm saying? So 20 take away 3 twice is 14. So we know the height is 14. Now we're going to plug this into the calculator, lads. So please write this down. It's 4 over 3. We're doing pi. Just leave it as pi in your calculator. Put 3 cubed. And then we're going to do pi 3 squared times 14. And we can probably enter that all in one go. No, we do. No, we do, because it's a calculation, not a solve. So there's no equal sign. So we're not crossing off the pi. Is it? And I think it wants it in decimals. So press the change button. Anybody lacking? Anybody else? Come and get it. Come up and get it. Oh yeah. All right, so we got 509 millimeters squared or cubed. I mean, 509 millimeters cubed. All right, how'd you rank that question on a scale of difficulty? So that fitment tablet we just used, there's 24 of them. Everybody understood? There's 24 of them in a capsule. The capsules are stacked in 3 rows of 8 in a box as shown in the diagram. How much internal volume of the box is not occupied by the capsules? Right, now this is awkward, all right? So look at this. I want to find the size of the box. Is that all right? Now, we're going to make an assumption, because this diagram is ever so slightly off. We're going to make an assumption that the circles are touching the outside of the box. Is that all right? So how wide do you think this box is going to be? Why am I writing 6 every time? But why am I writing 6, though? 6 is the diameter, isn't it? Because it's the same pills from part 1. So in part 1, 6. So 1 sec. So just go and grab this diagram here. I'm going to need it in a second to explain this question. Okay. So we'll just drag this downwards, and I'll tell you what we're doing with this in a second. Okay. Now, here's what's going on. So what do you reckon? Who says 48 by 18? All right. So is everybody happy that what do we have? 1, 2, 3, 4, 5, 6, 7, 8. So that's 48 this way. And then what about this way here? 18. Now here's the issue. It's 48 by 18, all right? Now, do you see this pill here, yeah? If I rotate that, see the way I rotated it? Okay? That's the way they're stacking the pills. So see the top of the pill. So see this part I'm shading in red? That's that part there. Does everybody agree with that? You're just grabbing the pill. You're grabbing the pill and you're rotating it that the heads of the pill are sticking upwards. Does that make sense? So what height would the box have to be then? What? Who said 20? Right. Reason being, it said the length of the pill is 20. So your box is going to be, as you said, it's going to be 48, 18, and it's going to be 20 high. Does that make sense? Okay. So what we're going to do here is, was to draw a rough diagram. It has to be a lot wider, doesn't it, than it is longer. And then Control D. Sorry. All right. Here's your box. All right. And if you're trying to picture this in your head, the pills are basically being stored like this, aiming upwards. Does that make more sense now? So there's row upon rows of pills stacked like this. Okay. So literally, this is what we're looking at, and that's one pill stored in position right there. Okay. So what was the width of the box again? 18, was it? And the length? 42 or 48? 48. And the height? We know the length of one pill is 20. Okay. And what does it say in the question? How much of the entire volume of the box is not occupied by the capsules? Don't worry. Let's just get the air. Let's get the volume of the box. So what's the volume of the box, lads? Let's get the volume of the box. How much? Millimeters. Cubed volume. Okay. How much of the internal volume of the box is not occupied by capsules? That's fair enough. Now, lads, how many capsules is there in a box? How many capsules is there? 24. Does everybody see 24 capsules? Now, what's the size of one capsule? We did it earlier. 509, we'll put it as, all right? So, lads, will you multiply 24 by 509? Prediction time. 24 by 509. I have a question for you, okay? Before you do it. You ready? If 78,280 is the size of the box, do you expect 24 tablets to be bigger or smaller than the box? Exactly. Put it in and see if it's smaller. 12,200 and? Excellent. So here's what's happening. We're asked for the percentage of the box that's not occupied. So the box size is 17,280. What fraction of it is not occupied? So take them away from each other. What you get? Once you take them away from each other. 5,000 and? Okay, so 5,064 out of the 17,280 is not occupied by the tablets. Multiply that by 100 and it'll convert it into your percentage. So what do we get? Anybody? 29.3%? You all okay with that? An ornament is carved from a rectangular block of wood, which has a square base. So originally it's a square block of wood. Everybody got that? Or a box-shaped wood, yeah? And what happens is you cut two spheres out of it. Okay? So the ornament consists of two identical spheres and two identical cubes, as illustrated. Now remember, cube means length, width, and height are the same. The diameter of each sphere is equal to the length of the size of each cube. Okay? So find the length of one side of the cubes. Any ideas what to do here? Who said divide by 4? You're correct. This blue length is the same as this red length. It's the same as this green length. It's the same as this purple length. They're all meant to be identical. So what we're doing, 24 by? You got 6. Everybody cool so far? Okay. Next thing. Find the volume of the ornament. All right. Okay. The cubes are length by width by height. That's for cubes. And what is the length, width, and height of that cube? Yeah, it's a 6 by 6 by. That that will get you the volume of 2 cubes. How'd you get the volume of the spheres? 4/3. Now, what's the radius? Yeah, it's 3 because the. Yeah. Okay. So, and what you get for the volume of the cube? Who did 6 by 6 by 6 centimeters cubed? Okay. Shh. Who got the volume of a sphere? So it's a 4/3. So what you get? So 113.1. Is that right? Now, lads. So, guys, there's this blue one is the size of a cube. We're going to double it, and then we're going to add it to. We're going to double the sphere because there's 2 spheres. We're going to add them together, and what do we get? We got 658 points. I'm going to get 658.2, but it's roughly the same answer. Who got that? Yeah. So radius is half the 6, which is the 3. Yeah. Cool. Shh. Lads, in making the ornament, what percentage of the original wood block was carved away? Now let's calculate the size of the original wood block. Anybody care to tell me what you think the size of the original wood block would have been? Right, 24 in height, six across and 6 back, so 6 by 6 by 24. Yeah. So let's do that. 6 by 6 by 24. 864 centimeters cubed. Lads, didn't the answer have to be bigger than 658? Why? It's the original that we cut away. All right. So take them away from each other, and we find the amount of we find how much of the wood we carved away. So let's take these 2 answers away from each other, and we find out how much wood we took away. Come on, Carl. Focus. How much? Yeah. So, lads, you lost 205.8 out of the 864 you started with, and you're going to multiply that by 100 to find out what percentage you lost. What do we get then? 0.8. Is that okay? What you